Hello, I am Pietro Fontolan, and today I'll be presenting my final project, Identification of Artists from Paintings with a Deep Neural Network. The goal of this project is to train a deep neural network in such a way that, given the image of a painting, it can correctly identify who the author is. This is both a computer vision problem, because the network has to analyze images of paintings, and a classification problem, because the network has to properly classify an image as belonging to a class. In this case, the classes are the authors. The dataset used to train the network is called Best Artworks of All Time, and it can be freely downloaded from Kaggle. It is released under the Creative Commons license, and it consists of 8,000 paintings from 50 famous authors, ranging from the 13th century to present times. Here are some of the paintings of the dataset. Let's make some observations now about the quality of the dataset. The images are quite good, centered and without borders, so the overall quality of the dataset is good. However, the number of images per painter is uneven. We go from Jackson Pollock, who has only 24 paintings, to Vincent van Gogh, who is represented by almost 900 paintings. And this can be a problem because network results are less reliable for authors with few paintings. Moreover, this dataset is challenging because it doesn't have many images, but it features a lot of different painters, and it covers a wide range of centuries with certainly different painting styles, but also it hosts painters with very similar painting styles, and maybe it's difficult to distinguish among them. The dataset needs to be prepared properly. It has been split in training set, validation, and test sets with percentages 60%, 20%, and 20%. And a generator pipeline was built. It allowed us to resize the images properly according to what is required by the neural network, to rescale the pixels to the range 0 to 1, and to augment images. But we have to be very careful because image augmentation could be harmful in this case. Shearing, zooming, and rotation can be misleading because they muddle up the painting, and maybe they make author recognition much more difficult. So only horizontal flipping was allowed. Class weight was very useful because it is possible to assign a weight to each class, inversely proportional to the number of paintings in that class, taking thus into account the different number of painters in each class. The technology used. I used TensorFlow with Keras version 2, and as hardware I used a Linux server with 1 GPU and 12 gigabytes of RAM. Since we did not have many data, I decided to use a transfer learning technique. I chose a state-of-the-art neural network for computer vision, which is Inception ResNet v2, pre-trained with ImageNet weights. I used this model as a starting point for my task. I removed the top classifier, which had been trained before to recognize objects in the ImageNet dataset, and added a new classifier to be trained from scratch with the new dataset to recognize painters. So I have a new classifier to train from scratch, but I use the same convolutional base with the same features learned from ImageNet. As we will see, this can have some drawbacks, because recognizing a painter is a different task from recognizing an object, but at least this is a starting point. In fact, the results are not very good. accuracy was only 46%. I decided then to do some fine-tuning of the convolutional base. I unfroze 10% of the deep layers of the convolutional base, and accuracy improved to 66%, and this is quite a good improvement. Then I did some experiments. I tried to unfreeze 50% of the convolutional base and got a validation accuracy of 72%. At the end of the day, I unfroze all the convolutional base and got a validation accuracy of 77%. Well, this means that high-level features trained on ImageNet are not very effective for our task, and that a deep retraining of all the convolutional base is required. Features useful to recognize an object are not useful to recognize a painter, and this is true for all the levels of the convolutional base. In fact, also changing very basic low-level and not specialized features provides an improvement. It is possible that features that depend on low-level features, on low-level characteristics, such as brush strokes on the canvas or the colors used, provide useful information to identify a painter. I trained the model for 50 epochs and then another 10 epochs, but then the network started overfitting. And as I said, I got a validation accuracy of 77%. I tested the result on the test set, and the validation accuracy of and the accuracy was confirmed to be 77%. Here are some of the results I got. The names in red are prediction errors, so this is an error and this is another error. The names in blue, the other names, are instead correct predictions. Some observations and remarks. As I just said, high-level features trained on ImageNet are not very effective to predict the author. This means that painter recognition is quite a different task from object recognition. The features used to recognize objects are not useful to identify a painter. Therefore, retraining is necessary at all levels, from swallow to dip. Another observation. I also computed test accuracy for each single painter. And in the plot, we can see test accuracy in blue for each painter, and also the number of paintings used in training for each painter. I was looking for a correlation between the two quantities, but I found none. There is no clear correlation between test accuracy and the number of paintings used in training. Take, for example, this painter here. This is Caravaggio. He has a high accuracy in spite of the small number of paintings used in training. This other painter here is Vincent van Gogh. We have a very high number of paintings used in training, but accuracy has a middle value, we can say. So a big number of paintings does not automatically imply high accuracy. And this means that some authors are inherently more difficult to identify, no matter the number of paintings provided. Another observation. I wanted to investigate the effects of image augmentation on accuracy. Does it reduce overfitting? Does it provide better accuracy or not? So I added rotation, shear, and zoom to the training image generator, retrained the network, and evaluated the network on the test set again. And what happened? Test accuracy fell to 56%. In this case, image augmentation is harmful. It doesn't provide any advantage. And this does make sense, because image augmentation can distort a painting in such a way that the identification of the author is much more difficult. And now some conclusions. We can say that the technology proposed can be used to solve the problem, and the results are quite good. However, there is a room for improvement. The main problem here is overfitting, which prevents us from getting better results. To improve, it would be useful to have a dataset with more paintings per author, and also a more balanced dataset with more or less the same number of paintings for each author, if that's possible. Another thing to try is to use other architectures like ResNet 50 or VGG 19, which are widely used image recognition networks. Another interesting thing to do is to apply dimensionality reduction to the features learned by the network and see if painters can be grouped together. Which painters look similar to each other for the network? And are painters belonging to the same school, for example, the French Impressionists, in the same group according to the network? But that's for the future. For now, thanks for watching.